I've been doing a couple reviews on 3D printers lately, specifically resin 3D printers. Now those resin printers are really great for small detailed parts like new wheels, disc brakes, calipers, and other interior detail stuff and pretty much anything finely detailed you can imagine. What they are not really good at is really big parts and more specifically really structural parts and even tools for around the workbench. The parts from resin 3D printers are really fragile and brittle and aren't really usable for the more structural and even tooly side of the parts. The printer that GeeeTech sent me out is a printer that does not really print in resin, but it prints in actual plastic. There are a lot of different filaments out there, but I'm just going to be printing with PLA. That is a type of filament, and filament is of course the material that comes out of the printer and creates the part. PLA is a type of plastic. After unboxing the printer, there was a small amount of assembly that needed to take place before I could start printing. That took about an hour just plugging in all of the wires and a couple of screws to attach the top section with the X, Y, and Z all together. I put the spool of PLA on top of the printer, inserted it into the printer, and started with the first test print. The first test print completed, I then moved the printer upstairs to its permanent position and out of the living room, of course. With the printer now moved upstairs, I could move on to printing a couple more parts, and specifically the structural and tooly parts that I want for my workbench. Now, of course, before you can start printing, you need a slicer. GeeeTech has their own slicer, but since I have a Mac computer, they don't have a specific software for that. I decided to use the one from MatterHackers. Now, the printer is not in this system from MatterHackers, so you need to create a custom printer. Just type in all of the specifications from this printer and you're good to go. In this case, the A20 has a print bed of 255 wide and deep, and also a height of 255 as well. The bed is of course half the width and also depth, and that is 127 in this case. And then the nozzle that is included in the printer itself is a 0.4. Once the custom printer has been created in the program, it is time to add the files or just create a new part entirely with the MatterHacker slicer itself. As I mentioned before, there are multiple websites like Cults 3D or even Thingiverse where there are a lot of 3D files already pre-made, and you can use those. But you can of course just create some yourself if you're good with 3D modeling on the computer. In this case, I took one of the parts for the bigger piece that I'm printing, and that is a bolt, set the layer height at 0.2, infill at 70%, and then started trying to figure out if it needed supports, which it didn't, so I could just remove those and export it to start printing. The file is now created and inserted into the printer, so we can start printing. The file is selected, and then the printer can start working. So at the start of every print, the print bed itself, in this case, is preheated and needs to heat up to 55 degrees. This is 55 degrees Celsius. And the print nozzle, where the plastic melts and comes out, needs to be heated up to 205. You can see on the screen itself a nice display where it shows how hot it is and if it is there yet. Of course, the spool of plastic, in this case PLA, is added as well. There is plenty on there. It's inserted into the nozzle and tube, and then the printer can start printing once it has reached the temperatures. The printing process always starts off with a couple of base layers to make sure that it sticks properly to the build plate itself, and then starts on the main model. Now in this case, I decided to print just a small part to be able to add a nice time lapse for you guys, but the bigger the part gets, the longer the print takes, of course, and the more infill the part has, the longer it takes, as well as it does have to do more passes and more layers. Now in this case, I just want to tell you a bit more about the printer itself. This is one of their entry-level printers. It does already come with a heated build plate. Now not all 3D printers come with this, but specifically with these plastic printers, the heated bed is really important as it helps stick the part to the plate and also keeps it from warping. Now there are different options you can add onto this printer, but of course that makes it more expensive and also does help you along with the printing process, but are not necessary. For instance, there is a module for a Wi-Fi connectivity and also an automated bed leveling system. These can be bought directly from GeeeTech if you're interested. Once the print was complete, I quickly removed it from the build plate itself after that was cooled down a little bit, and then could start removing all of the supports in the threaded pieces. This part was printed at 0.4 millimeter layer height, so that's a pretty big layer height. Just to detail it out even more, you can tone that down to 0.2, and the part will get even stronger and have nicer details. I decided just to play around with the settings a little bit more. First time around I printed this bolt with a 0.4 millimeter layer height and a 40% infill just to see how fast it could print one of these, and just added some random supports here and there around the threads to keep them nice and tidy. As you can see, the print lines are really visible and it doesn't really look that good. Then I tried the print again at a 0.2 layer height. The print is a lot nicer. I didn't even need to add supports, and all of the threading on this screw is a lot nicer. The print lines are of course still highly visible, and that will always be the case with these prints, but it is still a lot better than the first time around. It did take about 20% longer to print, but that is really well worth the time. I also found out on the website of GeeeTech, where I got all of the parts from and also the PLA, that there are specific settings for the PLA to print them correctly. In this case, I bumped up the temperature of the preheated bed to 90 degrees and also raised the temperature of the nozzle itself up to 240 degrees. I previously had it set to the standard settings from the Matter Hacker slicing program, and that was 205 for the nozzle and 55 for the print bed itself. Changing these settings really improved the way that the prints came out. So with 3D printing, there are a lot of different options. You have resin printers, there are metal printers out there as well, even some sort of CNC machines you can buy for your desktop. And of course, the printer that I'm showing you here is a PLA printer. This prints in various different layers, melting some plastic and going around the entire model until it is completed. Now, the downside to this is that it's not super detailed and it does have pretty visible print lines. The upside to this is that the parts are super strong and really usable. Now, for instance, when printing parts with a 3D printer that does resin prints, the parts are pretty brittle, but are very highly detailed, and in some cases you can't even see the print lines. Those parts are of course perfectly fine for printing wheels and small details for the model cars we like to build. Now in this case, I'm also building some tools for on my desktop. As you can see, I printed a holder for some of my glues and Decals Solutions, and even some setting solutions for the glues as well. And this is a perfect example of what you are capable of printing with one of these printers. Now let's say you've printed this with a resin printer, then these edges are really fragile and the part probably doesn't hold up all that long. If you drop it one time, it probably breaks. Now in this case, the part is made out of plastic. It is super strong and holds the pieces in really well. Now another idea is to print some tools for your resin 3D printers. Now this one is not yet finished. I printed the base and also the funnel and a holder for some of the filters, and one of the other parts as well. These are purely functional parts. Now they aren't super nicely detailed, but they are very strong, and that is one of the upsides of these printers. So the base that I printed here is a pretty big part. It has some nice structure here and is about a 40% infill. You can't even really bend it all that much if you try really hard, let alone break it. And that is why I'm deciding to add one of these printers as well to my lineup of printers for some of the tools and other usable stuff around my modeling bench. So I'll show you the 3D model of what this is supposed to be, and I'll leave a link down in the description as well. And also, of course, this part here. It is a really nice thick part. All the pieces fit in nicely and hold it together so they don't fall over on your workbench when you accidentally just tip them over. Same goes for the glues, of course. Now, when I got the printer, it had a file on the SD card as well of this dog. This is their test print, and it came out really nice. I think it had a layer height of 0.1 millimeter. For instance, a resin printer does 0.01 millimeter, so that's a tenth of this. And that just shows how capable these printers are, and of course how capable those resin printers are, of course. Now, when printing detailed part like this, it's not ideal to do it with a printer that does PLA printing. I'd suggest to do it with one of those resin printers, as that captures the details a lot nicer. But you can still see that it does a really nice job. The lines are of course still visible, but then again, this part is a lot stronger and more structural than the other parts from resin printers. So just to get that out of the way, these printers are not for super detailed parts, but they are more for the structural and usable parts like the tools and stuff I mentioned earlier. I would recommend one of these printers as they aren't really expensive, but are a really good way to get into 3D printing and also learning about it a lot easier than using some of these resin printers. The cleanup is a lot easier, just wipe the parts off the plate and start over again. And with resin printers, it's about a 30-minute cleanup every single time if you mess something up. And then, of course, you have to figure out what exactly went wrong, and that can get quite frustrating. So I'll leave links down in the description to GeeeTech. If you want to know more about these printers or anything about their company, feel free to contact them. I hope you guys enjoyed this video and see the use of these 3D printers. And if you have any questions, feel free to leave them in the comments section down below, and I'll see you guys in the next one.